Hi there, how you going? Andrew Dunkley here. Great to have your company again on another edition of Space Nuts. Coming up on this episode, we're going to be looking at, Mars. Gosh, when was the last time we did that? About a week ago. But good reason for it, because they've made a discovery that is mind-blowing. Lots of things on Mars are bigger than they are on Earth, even though it's a much smaller planet. This is one of those. We're also talking archaeology. Now, when you talk archaeology, you're thinking of people digging around in the dirt looking at bones. No, they're looking at dirty socks on the ISS, amongst other things. Or maybe not specifically socks, but the International Space Station, yes. And the link between science fiction and real science. There's a fascinating story that talks about that as well, all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here to discuss it all and talk about the shopping list from last week is Professor Fred Watson, astronomer at large. Hello, Fred.
Well, there's bacon, there's cornflakes, there's soap, all on the shopping list from last week, so plenty to talk about.
That's all processed food, even the soap.
Yes, even the soap, yeah.
Apparently that's... pardon?
Do you eat soap as well, yeah?
Oh, I did when I was a kid. I was a pretty stupid kid, though. But apparently it's very good for catching mice, is soap, I'm told.
Well, there you go. That's interesting. Yes.
I don't know how true it is, but I've never tried it.
Throw it at the mice, or
you put it on the mousetrap, and then yeah, maybe it's the smell that gets them in, and bang, you got it.
Well, that's right. Could be. Yes.
I don't know for certain. Shall we just get started, because we've got a lot to get through?
Yes, we should.
Okay, let's do that. Our first story today involves the red planet Mars, and as I mentioned at the very beginning, it's a place with some of the biggest things in the solar system, the biggest mountains, the deepest canyons, and now it looks like the largest lake. It's a really fascinating place for all of those reasons and more, Fred.
Yes, it is, and in some ways, this is a bit surprising, because we know that probably most of Mars's northern hemisphere in ancient times, and by that I mean 3 to 4 billion years ago, probably had world water on it. It probably had an ocean that basically covered it. We don't know whether that ocean lasted a long time, whether it was something temporary or whether it sat there for hundreds of millions of years, but it definitely had its effect on the landscape. But this story is from, actually, it's kind of the equatorial region of Mars. In fact, it's actually in the southern hemisphere that we're talking about. So not that far south of the equator, I think from about minus 25 degrees. What we have there is a much more highland region of Mars. That's where a lot of craters are, where there are a lot of mountains, and it's a region that you wouldn't expect to be home to large bodies of water. But images from the European Space Agency's Mars Express, which has been photographing Mars from above, I don't know, probably about the best part of certainly more than 10 years, probably more like 15 years. Mars Express has not only photographed the surface of Mars, but also, as it has orbited the planet, it's got ground surface radar, so you get very accurate topographical maps. And it's by studying those maps that scientists based at a number of institutions in Europe have, what they've done is they've looked very carefully at the topography of a region which is quite a large region of Mars that encompasses several regions: the Ariadnes, Colles, the Gorgonum Chaos, the Newton Crater, Caralis Chaos. All of these are zones on Mars. Turns out, though, that you can lump them all together and you can draw a contour around them. And you can also, from that, work out that that was once a shoreline. And from that, you can establish that, and it's not just the appearance of this. I think the chemistry actually also backs this up. But you can work out that there was a very large lake there, which has a name. It is called Lake Eridania. And Lake Eridania, as I said, 3 times bigger than the biggest lake on Earth, which is the Caspian Sea. So it's a colossal body of water, or it would have been when it was wet. It's not wet now, but the evidence is all there. And there's so much geological support for this idea that to some extent it's surprising that we haven't been talking about it before. But yes, much is being learned about this region of Mars. And it may be that it also involved geothermal activity. When that water was there may well have been geothermal vents on the floor of that lake, which have given rise to some of the interesting chemistry of the minerals that we find on that region. So yeah, really interesting story from a planet that it's the planet that keeps on giving, really, isn't it, Mars?
Yeah. So 3 times bigger than the Caspian Sea, which is the biggest inland body of water on Earth, and it measures 371,000 square kilometres. So we're talking what, 1 to 1.2 million square kilometres of water?
Something of that sort, that's correct. About 1.1 million square kilometres is the estimate from the scientists who've done this work. When you think of a body of water like that, you think in terms of oceans. It's not an ocean. It's basically bounded by land, unlike the ocean in the northern hemisphere, which certainly was bounded on its southern border, but probably covered the polar region as well. So it is, it's what you could perhaps call an inland sea or a lake, but whatever it was, it's a lot of water. Really quite extraordinary evidence for its existence too. The paper that we've been looking at, and there's a very nice summary of it on University Today website that shows some of the evidence as to why we now believe that this lake existed.
Yeah, it shows that, it confirms, I suppose, previous theories about the abundance of water on Mars. Do we have any idea what kind of water it might have been? Has that sort of been considered?
It was probably wet.
Was it salty?
Look, it might have had, because of the fact that the scientists have really looked very closely at the minerals that have been deposited on the floor of this extinct lake, in particular chlorides around the shoreline, and which may be related to the volcanic activity. The suggestion is that it would have been quite rich in minerals. So yes, salty is probably a good way to describe it. There's some very interesting chemistry that I think is being studied in relation to this. So very fine piece of work.
Could it have existed long enough for some kind of microbial life to exist?
$64,000 question there.
Yeah, it is.
Maybe it could. Maybe you could find evidence of life there. And I suppose the reasoning will be very similar to why Perseverance is in Jezero Crater at the moment, because that's a place where where definitely was a river delta, which is thought to have deposited material brought down from a long river system, quite a long way actually from the region we're talking about at the moment. But it's a place where you expect the sediments to have been dropped to the floor of the crater in the case of Jezero Crater, and they might carry evidence of microbial life, as we talked about not very long ago. And it's possible that this lake, Lake Eridania, might also have the same sort of properties, that maybe the sediments on its bed, which in some cases were almost a kilometre below the surface. It's a deep lake. It's not just a shallow stretch of land. So that there may be evidence to be gained if somebody felt like sending a spacecraft there to have a look.
Oh, yeah. Yeah, it sounds like it's a prime target for future
Maybe
investigation.
so, yes.
Yeah. And the volcanic activity that went along with it may well have, we talk about volcanic activity in the depths of our ocean where life is abundant. So, could that kind of scenario have existed in this particular lake on Mars? Who knows? We're talking about a time frame of 3 to 4 billion years when this lake existed, but it took a long time to disappear, from what I can tell.
I think that's right, and that's one of the areas of interest in terms of research on Mars. How long did it take for Mars to become a dry, cold and dry world rather than a warm and wet world? In fact, it's a question we've had from Space Nuts listeners as well. How long did that process take? And it probably took quite a long time. And it may have occurred in episodes, Andrew, where you've got a wet period and then a dry period and then a wet period, and the dry period just gets that bit longer than the last one was, and before you know where you are, you've dried up the whole thing. And we'll never really be able to play a movie of that, but I'm sure the evidence will build up as to what kind of duration these water systems had.
Yes, indeed. Imagine if humanity had time to evolve on Mars and then came to the realization that their planet was dying. That would be a horrible thing to discover.
It sounds like a science fiction story, does that? The start of a science fiction story, yes.
Yeah. It's called Three-Body Problem.
Yes,
actually.
That's right. Yes.
That's what it's about. But I mean, imagine if we right now made that discovery. We are not yet technologically capable of doing anything about it in the short term, and we certainly aren't in a position to say, all right, let's leave because this place is not going to be worth hanging around.
Well, there's already one person who thinks like that.
Yes, there is.
But no, the odds are that you'd have a very long lead time for that kind of thing, and just hope your technology catches up, which it probably would.
Yes, indeed. All right. As Fred said, if you would like to read up on that story, great article on universetoday.com. This is Space Nuts, Andrew Dunkley with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, to our next story, and that is archaeology. Now, archaeology is the study of historical artifacts to learn about the people and places of the past. That's a pretty loose definition. There's all sorts of variations in what archaeology is and what it's trying to achieve. But we generally think about people, with their little brushes and spades digging around the dirt, looking for Triceratops skulls and digging around the ruins of Pompeii, for example. But this is archaeology with a difference. This is photographic archaeology, courtesy of the International Space Station and its onboard crews as they changed and did their work over the last 2.5 decades. And they're coming up with some interesting stuff.
They are indeed. Actually, one of the authors of this work is an Australian colleague, actually, somebody I know not terribly well, but I do know her. Her name is Alice Gorman. She's very well known as a space archaeologist here in Australia. She's at Flinders University. So that is, the preface to what I think is a really interesting piece of work. And what has happened is that Alice and her colleagues have applied standard archaeological methods to a very non-standard environment, namely the space station. They've basically divided the space station up into 1 meter squares, all the surface area. And that's what you do in archaeology. You divide your archaeological site into a grid of 1 meter squares, and then you take excavations of some of those squares, which are known as test pits. And so you dig your pit, 1 meter square, and that gives you a sample of what kind of stuff there is in there. And so the scientists who've done this work have obviously collaborated very strongly with the crew of the International Space Station, which itself is a movable feast because in the 23 years or 24 years that it's been inhabited, something like 280 people have visited it. So
Yeah, that blows my mind. I would never have put it at that many.
Yeah.
Wow.
Yeah, it's a lot. So that large number, some of the recent inhabitants have been not co-opted, but have been collaborating with the archaeologists to do what archaeologists do. And what they've done is laid out 5 what they call sample areas, which are roughly a metre square, to follow standard archaeological practice. There's a very nice conversation article about this. So I'm going to read from that because I think it's probably put better than I could put it. We chose the square locations to encompass zones of work, science, exercise and leisure. The crew also selected a 6th area based on their own idea of what might be interesting to observe. And there's actually a nice acknowledgement there. The study was sponsored by the International Space Station National Laboratory. And what they've done is they've given the space archaeology exercise a name. It is an acronym.
I love it. I love this.
It's a good one, isn't it? It's a good one. It's the Sampling Quadrangle Assemblages Research Experiment, or SQUARE.
That's very clever.
Be there or be square. That's right. So they're square. What they found is really interesting. Some of the areas that they've sampled are very busy areas, on the way from one part of the space station to another. There's a rather nice summary here in the conversation article. The space station is cluttered and chaotic, cramped and dirty.
I knew the dirty bit.
Yeah, there are no boundaries between where the crew works and where they rest. There is little or no privacy. There isn't even a shower. That sentence actually reminds me of the Vogon destructor fleet, because that was all full of old mattresses.
Mattresses?
Yeah. It's probably like that.
Yeah.
Anyway, so they've analysed the conversation article that these authors have written analyzes the first 2 squares, and one I'm reading again. One was located in the US Node 2 module, where there are 4 crew berths and connections to the European and Japanese labs. Visiting spacecraft often dock here. Our target was a wall where the maintenance work area is located. There's a blue metal panel with 40 Velcro squares on it and a table before for fixing equipment or doing experiments. And NASA intended the area to be used for maintenance. However, we saw hardly any evidence of maintenance there and only a handful of science activities. In fact, for 50 of the days covered by our survey, the square was only used for storing items which may not even have been used there. So it's because the amount of Velcro there, that made it perfect for storing things.
Yeah.
It says close to half all the items recorded, 44%, were related to holding other items in place. So
that's amazing.
Yeah.
Yeah. I suppose one of the things they've discovered from all of this is that if they're going to build space stations in the future, and they probably will, they need to consider things like storage. I mean, even when we were selling our last house, one of the feedback things was, where's all the storage? We need storage.
Yes.
Want more storage. Well, it sounds like it's exactly the same for the ISS, and it's only being discovered through the people who've lived and worked there for the last 20 plus years. And you're seeing things that were built with certain intent not being used for that purpose at all.
Yes, that's right. Yeah, exactly.
So, they might have to sort of redo the blueprints on future space stations to deal with the needs of those who are living and working there. And another example was, I think it was like a vanity case that someone had.
Yes, that's right.
That spent 60 days stuck to a wall near the bathroom or whatever, the toilet, near the toilet.
That's right. They never found out who owned it.
No.
But it was just there. So that's the second area that they analysed. It was perhaps a more interesting area. It was sort of where the exercise machines were and the toilet, and it's a passageway to the cupola window, which is one of the best places probably on the space station. So again, there was a wall with no particular function, but it got everything stored on it, including this anonymous toilet bag that we just mentioned. So really very interesting to find that. And I think you're right. You're highlighting the right thing. It's all about storage, where you can put things.
It also shows how humans take advantage of the opportunities of the space they have to deal with whatever needs they have. So, and I think it changes from person to person. And with 280 plus people going up there and more to come, because I think they're not going to bring the ISS down for another few years yet, but it's a case of, all right, I'm new. I need to find space for my stuff, and you adapt. Yeah, and that's what's being revealed in this archaeological study, which is being done, I think you said, through photographs.
Yes,
people on board taking photographs of these particular 1 metre square spaces to see how they evolve and change. And it is fascinating stuff. And a one-off opportunity, really, because when that space station's over and done with, all that information will be gone.
That's correct, absolutely. But your reasoning's right on the money, Andrew. That given things like the Gateway space station, which is planned to be in orbit around the moon, a sort of gateway resource for people to dock with before they take the journey down to the moon's surface. All of this archaeology is going to feed directly into all the sort of amenities that need to be included in the Gateway station. And the answer is probably going to be exactly what you said: storage. That's what we need. Yeah,
and when you haven't got much room, I suppose you do have to take advantage of whatever opportunities available. And if someone's built a wall with stacks of Velcro on it,
that's right.
It's going to be a very tantalising opportunity to put your stuff rather than use it for what it was built for, which I think in this case was supposed to be maintenance.
Yes, that's right.
So, very, very interesting indeed. And it is a good article. I actually read the whole thing start to finish and absorbed it all on the Conversation website. You're listening to Space Nuts. Andrew Dunkley with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now to a genre that I am much invested in, and that's science fiction. But this is a story about science fiction and science fact and how they have sort of collaborated and dovetailed so beautifully together. This is a really great story, Fred.
It is, and it's. I'm going to let you talk to this one because it's very much up your street. But basically, it's a researcher is actually the director of research at Laboratoire d'Astrophysique de Marseille, down there in the south of France. Is a gentleman by the name of Samuel Boissier. So he's done this work investigating the relationship between science and science fiction. It's especially against the backdrop of the era that we live in now, where you've got misinformation, you've got deep fakes, you've got, basically attempts to distort science, all of that sort of thing. The good old conspiracy theories, all of that is distorting our view of what science is all about. And so it's an interesting context in which to put this study of the relationship between science fiction and science fact.
Yeah, I think there were two keystone things that came out of it, and that is that science fiction has a place in that it can inspire people to look into careers in science. Even though science fiction is what it is, it's the imaginations of writers and filmmakers, for that matter, coming out in paper or on an ebook or on a TV or a big screen. But it does have a place in the scientific community because it has been successful in inspiring people to get into those fields of education, or those fields of expertise is what I'm trying to say. The other keystone to come out of this is that science fiction can also educate. Even though the stories are coming from some incredible minds, they have been built on the back of real science. And so they educate. Kim Stanley Robinson's Mars series is a very good highlight in terms of teaching people about not just what Mars is like, but what it could be if we develop technology to turn it into a livable planet, which is what the Mars series was all about. The movie Interstellar was created using real science. They used, and some of it was pretty well stretched.
Yes, it was.
And the Martian was a science fiction film, but it was so close to being really possible because of the consultations they did with scientists and astronomers. It looked feasible in many respects. So there's a lot that works in and around science fiction and science coming together. And I think this is a really great story. And when you look at some of the early science fiction writers, they didn't have the science to back up their imaginations. They had to think outside the box. And even some of the really early ones that predated the rocket era came up with rocket ships as they are today.
Yes, that's right.
Yeah, so their brains worked in incredible ways. And as someone who's written science fiction, I just let my imagination run wild. But I'm not in the caliber of the Isaac Asimovs and Arthur C. Clarke's of the world, who are some of the greatest of all time, and have written some of the classic sci-fi stories. But I've tried to work it into what could be conceived as feasible if it ever came to be, which it probably won't, but that's the nature of science fiction. But some of the homework that goes into these stories is based on real science, and some of the people who are working in science today have been inspired by stories from the imaginations of great people. And that's what this is all about. And I think it's fantastic stuff. I really am. I'm delighted by this story, to be honest.
And I mean, going back to that old chestnut, my all-time favourite science fiction story, the movie that came out in 1968, 2001: A Space Odyssey.
Yeah.
I remember after I'd watched that thinking that all of that was entirely possible. The idea of by 2001 we'd be having regular flights to the moon, we'd have artificial gravity space stations, we'd be able to send a spacecraft out to Jupiter to investigate things that were going on. I can't remember which way around it was. It was Saturn, either Saturn and Jupiter. I think it was one in the movie and one in the book, and I can't remember which way around it went. But all of that seemed absolutely possible back in the 1960s, and even the space warp, the sort of warped space interdimensional dive at the end of it, likewise seemed like an absolute possibility. So it certainly stirred the bosom of my science fiction heart at that time. I was a young scientist just starting out in my career.
I watched the TV series The Expanse. I've watched it twice, actually. And it too is sort of looking at humanity living across the entire solar system from Mars, Earth and Mars, right out through past the gas giants into the deep reaches of the solar system, and how it's sort of factionalized. So you had Earth and Mars at loggerheads, and the people who lived in the outer belt, they called them belters, strangely enough, and they all the tensions that existed between them. I see that as feasible.
Yeah.
But within the story, there were technologies that might exist today, but not to that level. For example, they didn't overcome the problem of zero gravity in space travel. So there wasn't artificial gravity, and we still don't have that today, but they overcame movement around spaceships by having magnetic boots.
Yes.
Which, seems so very logical. And you could turn them on and off as you needed to, electromagnets in the bottoms of the shoes. So you walked around on metal decks. And that's how they solved the problem of no gravity in space. It was a remarkable series and very, very cleverly done. And it sort of showed human nature to a certain degree, because we all hated each other and wanted to kill each other. Yeah. Because we had different beliefs and different needs, and the people in the outer reaches, the Belters, felt that they were slaves to Earth and Mars, and they hated us all. And it was really cleverly done. But that's the point we're making with this story, is that these science fiction stories come so very close to being real, to the point where they can inspire future scientists and they can inspire future invention. Who knows what the next big idea will be that will become a reality as a result of science fiction, and who knows who the next big scientist will be, because they are fans of science fiction. It is a really great and refreshing story. I'm glad somebody did some work on looking at that link. It's brilliant. Have we covered it enough?
I think so.
I got very excited. I can tell.
I can tell.
Yeah. No, it's a great story. And if you would like to read up on that one, I think that's in Universe Today as well, universetoday.com. The new study examining the links between science fiction and astronomy. So check it out. It is a great read. And don't forget to check out our website too, if you've got a few moments, spacenutspodcast.com, spacenuts.io. If you follow us on social media, don't forget to like us or follow us or add us to your favourites list, especially if you're on YouTube. Please hit the subscribe button. Fred, we are done and dusted for another day. Thank you, sir.
It's a pleasure. What a great set of stories we've had today. It's all good fun.
Yeah, they were fun.
Yep.
So they were a lot of fun.
Let's do it again sometime.
All right, let's. We'll talk to you soon. Thanks, Fred.
Yeah, no worries.
And thanks to Hugh in the studio, pushing all the buttons, pulling all the levers and flushing all the toilets. Thank you, Hugh. And from me, Andrew Dunkley, thanks for your company. Looking forward to joining you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.